Hello, everyone. How's the audio? Good? Okay. Cool. So I'm here to talk about peer-to-peer off the grid and some wacky projects that I've been involved with lately. So the first thing that I had was this mad science project called Peer Maps. And this was more a project that I was working on my own. It's a way to have a map that is, instead of just being based on like Google servers or even OpenStreetMap servers, it's something that different people can edit the map collaboratively, and their edits can be pooled collaboratively. So we can make these kinds of shared like wiki-style data models without having to pay for a lot of infrastructure and a lot of costs. So that was my crazy project, that was my project. But then I was contacted by this nonprofit NGO called Digital Democracy, and they have some real users who could put this kind of project to use in the real world. So the work that they do is it's sort of to inform the local political process in a lot of areas. So this NGO works mostly with indigenous communities in the Amazon rainforest in South America, primarily in areas that already have a kind of existing political structure that can that just needs kind of like tech support to help them out with the different technology challenges that you have, which are so much harder in an area where you don't have reliable internet or even reliable electricity. So some of these things are just having an accurate sense of territory can be a very complicated problem. You might have GPS coordinates and things, but the government maps might be quite old. Sometimes they're more than 50 years old. And the boundaries of rivers are perhaps wrong, or they go the wrong direction. All kinds of things can make talking and engaging with the political process difficult. And it's very good if these communities have accurate data, not only for their talks with other communities and their local government, but also internally, so that they're all on the same page and they can build consensus internally. And also there are a lot of environmental problems in some of these areas. So there's a lot of oil drilling that happens in the Amazon in Ecuador and Peru. And of course there's oil spills wherever there's oil drilling. And so these kinds of tools are really useful for just knowing what's happening and for doing something about it. So what I've been doing for this contract with this NGO is kind of a combination of like tech support almost, and also novel software development. So building tools that no one else is really building right now because these areas are so remote. But I think the main reason for that is it's just so removed from our experience here in the developed world. Like I think to really solve these kinds of problems, we have to think about, in a real world sense, like what are these challenges actually about? So as part of this work, in early May, I went down with Digital Democracy to this village in Wapishan territory. It's in the country of Guyana, which I'll show you, is right here. So this is Guyana. It's in South America, not in Africa. Common mistake. And the area where I was is right here by Lethem. And it borders Brazil. So there's this border issue right out of the gate. But there's also, it's the area that is indigenous territory is about 1/4 savanna and 3/4 rainforest. So this is a very remote territory that doesn't have an electric grid. Here's a picture of the Tusho, which is like the mayor of the village, Nick and Faye's building. This is a building called Benap that's really great. The picture on this side, it's sort of like a hangout area where all of your friends can come and you swing on hammocks, and that's also where we did a lot of the tech work. This is a chicken that kept getting in. There's a lot of chickens around. This one was very inquisitive and very persistent. I really like the picture of this chicken. So that's me in the shadows hacking, and this is the monitoring group. on the other side, and they're discussing like the actual work that needs to happen. So the tools that are used by the monitors, the people on the ground actually logging the data, the tools that they use are GPS devices, sealed Android phones, so relatively water resistant, although not necessarily. You could probably drop it in a puddle, and if you pick it up pretty fast, it'll probably still work, but often they don't. And also Windows laptops, which are running some software that we've written for peer-to-peer data replication. Also, some tools that we've been experimenting with are using aerial photography from drones, because the Amazon is a very cloudy place. It's rainforest, and wherever you have rainforest and a lot of standing water, you get a lot of clouds because the water evaporates, and it makes clouds, and then satellites can't see very well. So the data for this area is not very good. For a satellite like Landsat 8, I think, you might have a pass every few weeks, and you might get a few clear days out of the whole year where you can actually see something. So it's challenging to make maps in that kind of environment. Like, how do you deal with data acquisition questions? How do you deal with all of those kinds of things? So here's an image of the village just on somebody's computer there. You can see like the trees and things. This is much higher resolution than you would ever get from satellite imagery. Some of the other things to keep in mind for building technology that works in these areas is there's no electrical grid, something that all of us probably take for granted. You have really unreliable internet, and I'll get more into detail about the internet setup that they have there, and also the roads, simple things like transportation infrastructure. The roads are dirt, but they're largely navigable, except during the rainy season when many areas are only accessible by boat because the river swells up. So you can only travel to some areas according to when it's dry and when it's wet and how wet and things like that. So one very, very surprising thing about devices in this completely remote, completely offline place is that they're riddled with viruses, which you wouldn't think. They're offline. How could that be so? So people go to the main village that does have internet, or some of the communities have like a satellite uplink for 3G, and they copy games and videos and things onto their phone, and then they go over and they use Bluetooth to copy the files. Like in Android, you can do this. I've never done it, but everyone there is a complete expert at it because it's one of the few ways that you can transfer files. I think that's really cool. But all of the computers, including the phones, just are completely infested with viruses. And it's really hard to solve that problem because you don't have internet to install updates. Like, only the viruses can make it out into this community. It's really fascinating stuff. But I think that's also a good model for if you want to make data replication work in an area like that, make something that's like a virus, because that seems to work extremely well. Some other things. The power system is a bit mixed, so there's a lot of different ways that people get power. There's solar panels, about like a few 100-watt solar panel is provided by the government. So most houses have a small solar panel, and they'll charge like a motorcycle battery or a car battery or something, and you could charge your phone on one of those fine, and probably run music and a few lights, and it's okay. Also, people use vehicles a lot, and of course generators. So here's a picture of the solar charge controller in the village office in Schulenab, which was mostly red all of the time that we were there because we were pulling down a lot of power doing all of this tech work. And it's funny because they'd just gotten a giant new deep cycle battery that's very large and very powerful, but yeah, it doesn't matter. This is a little bit more of the setup, including the satellite modem, which is that device with the blue LEDs on it. But most of the power that people use to run things like computers are gas generators. So here's a couple of the villages behind the two shows house, and that's a little pig. There's a lot of really cute animals that all hang out around the kitchen, which is also right by the generator. All of the dogs and some pigs and chickens and things, because all of the scraps get thrown out and then they all feast. It's pretty adorable. Okay, so what is the internet like in this area? So pretty much anywhere you can get satellite internet, and it's sort of, well, first of all, it's pretty expensive. It's a few $100s a month for most plans, which is a lot of money in an area like Guyana. And also, the data caps are pretty small. So for a plan that costs maybe $150, $200, you maybe get 20 gigabytes of data. And then when you hit that cap of 20 gigabytes, the internet just stops working. So it's really easy to get into the kind of situation where if you haven't configured your computer or your phone to disable automatic updates, which you probably want because of the virus problem, you can easily exhaust the bandwidth cap in like a day if an Android update comes out, for example, and everyone in the village just uses up all of the bandwidth. And this is kind of silly because they're the exact same files in many cases, just downloaded again and again and again. It's very silly, but that's kind of what we have to deal with. So here's the internet on a good day when we were there. So that ping is 2,276 milliseconds, and the upload speed 0.3 and download 0.32. It took quite a long time to get this page to load at all. When I finally did, it was like fantastic. But on a typical day, you can't get, well, when I was there, you couldn't get any internet to work at all. Ping, for some reason, you can't really see it, but the maximum time there is 31 seconds ping, which I was surprised that it got back at all. It did. The lowest is maybe 3 seconds, or I see like 2 seconds, something like that. That's kind of atypical. Really, with satellite, you should be getting maybe 700 milliseconds, but that's what we had. And apparently, this situation has been fixed. Someone had to go out to the village and spend, I think, a few days just trying to get everything sorted out. It kind of works now. So some things that you have to do in an area like this, if you want to do simple things like put software onto phones, which are the main method of data acquisition in this kind of area, it's complicated because you can't just download them off the internet. You can't just go on the Google Play Store and click download, which is kind of a manual process if you have 20 phones, but you could do that. Instead, what we did is downloaded the APK file for the pieces of software that we needed to install in the phones, and then I wrote a little shell script here that you can see running. There it is. There's one of them that uses the Android ADB command to just copy the files one by one because we have offline imagery that we had to put on the phones. We had software that we needed to install, and this is something that I think could really use some better automation. But you know, the people who've worked on things like the Play Store and whatever probably don't consider this kind of a use case. So I think it's up to us to consider these things. One problem, though, with that approach of using a shell script is that it's not a self-serviceable thing. Like, I'm only in that area. Like, I was there once, and people are there maybe a few times a year from the outside, like, to help with the tech situation. So I think an ideal situation would be something that people can use themselves to service their own technology. Like, something, for example, maybe like a Raspberry Pi that can do those same ADB shell commands, but in a way where you push a couple buttons and then it's off on its way. Something ideally that's sealed and waterproof, and so that you don't get bugs and spiders coming in, because that also happens with some of these electronics. In terms of what I've actually been doing, so the Wapachan are, part of what they're doing is this territory mapping project. So here we have a giant plotter. You can't see it too well, but there it is. That's that big machine right there, covered with a plastic bag. So that's something you would use to print very large maps. Problem is that it doesn't really work on generator power very well. So you have to find just the right kind of generator that doesn't have a noisy signal for it to work at all. And then you've also got to be running the generators to power this computer because it had a cracked screen, so you couldn't see it. Also, the fan had stopped working. So Ron here had put a fan next to the laptop, like an actual physical fan that you might get, and it was blowing hot air over the laptop, and then also using an external monitor. So it was a bit of a crazy setup. But wouldn't it be nice if instead of having one person who did that with, you know, a kind of whatever technology still works over there, what if anyone who has a working device could edit these files? I think that would be a much better thing. And to make that use case work of having something that anyone can edit, I think a really good way to solve that problem is with peer-to-peer technology. So with peer-to-peer technology, we can start to remove these human bottlenecks. And you also get some built-in backups. So there's redundancy in the data model. And the other part, too, if you want to inform the local political process and get everyone on board with the same accurate evidence-based information, then if you can take any device and show other people what's been happening, then that's a very powerful tool, right? If you don't have to go into one of the main villages to look at the map computer just to communicate some information, that is, I think, a really good data model. So I think in this way, peer-to-peer and offline aren't super different. In both cases, when you start using these tools, when you're building an offline web page, you're already building a distributed system because part of the network is online and part is offline. And you can just take it a little bit of a step further, and then instead of only talking ever to a server, you can use what network capacity you do have. Maybe you have Bluetooth, maybe you have local Wi-Fi, something like that, to broker these communications. So one really good technique for doing this kind of stuff is to free your mind from the idea that if you have something like a key value store, that a key maps to a single value. And if you let that key map to multiple values, that kind of encompasses the diversity of opinion about what a key should actually be. And that's about the only true thing that you can say if you have that kind of data model. And of course, someone later can come in and merge those multiple heads back into a single fork. But that is going to work a lot better when you have people who maybe are not really expert users. They just are concerned with other problems like documenting the environment, that kind of stuff. Not wasting their time with solving a merge conflict, I think, is a really useful UX idea. So why JavaScript for this kind of stuff? Well, kind of in these areas, you've got to use what technology is around and what works. And so there are laptops, and we can run Electron. We can run web browsers on those laptops, but also there's phones. You can kind of run a web browser on a phone, but you could also run JavaScript with things like PhoneGap on those devices. And there's also question mark, which might be a Raspberry Pi running different scripts. It might be something else that we haven't seen yet, but I'm sure someone will, probably presenting today. And then we can also reuse a lot of the same ecosystem on NPM, like Level and Level Browserify, or there's a bunch of modules for doing chunk stores that we can repurpose that work in all of the environments that we might have to work with. So this project is called OSMPTP DB, and it's a way of implementing the OpenStreetMap schema, but in a way that works from the ground up with peer-to-peer in mind and with offline use cases in mind. So instead of talking to openstreetmap.org, you talk to something running on your own system. It might just be completely in your browser. It might be a server running on a laptop, but the important thing is that it can replicate using this thing called a kappa architecture. And so the specifics of how it works with this piece of technology is that there's this module called hyperlog that has an append-only data structure. So all of the updates are written to this log, and then there are different materialized views, which are just indexes that can quickly answer questions about what's in the log or not, that generate the different views that you can use to build things like a key value store or a spatial index, that kind of thing. So we have a server, the OSMPTP server, that speaks the actual OSM HTTP API. So you can plug things like ID editor into the system, which is what we've done. And then also another layer it's published, but it's not quite finished, that is going to be useful for collecting real media from the field. So if you take a photograph of something like a gold dredge, or you take a photograph of deforestation, or just a kind of natural resource, or something important to these local communities, like that they want to be in their map, whatever information that is can be put into this data structure using this module called Hyperdrive, made by the DAT project, and that will sync peer-to-peer for all of these files. So I want to mention a few of these kind of Lego brick ideas about that you can use to make your own peer-to-peer system if you want. That also will, of course, work offline, because you kind of get that for free when you build a lot of these peer-to-peer systems. So the first one is hyperlog. This is the append-only log that I was talking about. It's very easy to use. You call log.add with links, which are all of the predecessors to the current message. So it's very similar to Git, how you have a git commit hash, and then every new commit points at the previous hash, except here you can point at multiple hashes, which Git can also do, actually. It's how merges happen. And then when you want to replicate this data, you get a duplex stream, and you pipe 2 duplex streams together. And once that song and dance has happened, then both computers have the same data. And it works in a kind of distributed mesh way, so you can have these local connections that build up. And the final piece is hyperlog index, and this is what we're using to generate indexes, like the spatial index, like the key value index that speaks the OSM schema, because OSM is kind of based around a key value sort of an idea. So you can, then finally, we've got this piece hypercavey, and that just kind of wraps up some of those other pieces together with something that gives you a get and a put, except the get, remember, has an object of values or an array of values, not just a single value for any key. Okay, so what is the most reliable way to transfer information in this kind of an environment? One thing that we found that works really well is USB drives, sneakernet. So you literally take a USB drive, you put it in a laptop, you replicate to it, you go to the next village, maybe you're going there anyways, you plug it into their mapping computer, and the mapping computer on their end is also replicating, it's replicating the things that it has that are new to the USB drive and also getting the data. So you bring the USB drive back, plug it in your computer. Now both computers have the same data set. So you can take one instance of that idea and just farm it out to a whole community, and then all of a sudden you have a reasonable way of transferring files throughout an entire whatever kind of shared collaborative space you want to build. I have a small demo that I'd like to show you. This is the actual application that we've been piloting in Ecuador. So here, I think the map is over Brazil right now. So this is the ID editor interface. You can do things like draw polygons. You can draw lines and points. You can save. You can save your commits, and there it is. And then finally, when you want to replicate, you click this replication button, synchronize. You select the USB drive on your system, and then you can take the USB drive out, take it to the next village, bring it back, and now you're up to date. So the really cool thing is that on May 20th, this story got picked up by Al Jazeera, so I'm going to play a short movie clip just to show the part of the movie with the screenshot in it. So here's on Al Jazeera the actual application that I just showed you and I worked on being on TV. That's kind of fun. And so it's just in the, I think this was a story about the group in Ecuador, which I was helping to remotely debug. So that was pretty fun. Yep. So what is left to do? So we have a few things. An important piece for a system like this, sort of data acquisition, peer-to-peer replication system, is knowing when you can delete files, because these phones have pretty limited SD card space. So if you knew reasonably well that a computer that was robust and reliable also had a copy, maybe something off-site, maybe something like in the village office on a big hard disk that was also backed up, then you know that you could delete something. That would be a really important piece that you could also use these peer-to-peer data models to solve, except going in the other direction. Also, when you're replicating, you want to, maybe if you can't fit all of the big photos, you want to be able to have at least a thumbnail image that you can show someone else to say, hey, look what's going on in this area. There's something really interesting happening I want to show you. You should be able to do that from a smartphone. And I think that project I mentioned using ADB shell would be really fantastic for these remote areas too, because getting software onto phones and getting software onto computers is a really difficult problem when you don't have internet, and all of the assumptions that we use sort of depend on internet to be present. And that's maybe something that isn't always true everywhere. So here's some more links. I'll put these slides online in a moment. Thank you very much.